Good morning, students.
Good morning, ma'am.
Let us today start the new fresh session with the first chapter of chemistry, chemical reactions. Today in this module, we are going to study about chemical reactions, their characteristics, the representation of chemical reaction and balancing of chemical equations. Let us start with few examples in our daily life. We have all seen melting of ice, boiling of water, burning of paper and burning of coal. Which out of these reactions do you think are reversible reactions?
Ma'am, melting of ice and boiling of water.
You are correct. The boiling of water and melting of ice are two reversible reactions. Can anybody tell me why these two reactions are reversible reactions? No. Anybody? Just think. All right. So let's just think what happens when we melt ice. When we melt ice, solid water, which is ice, converts into liquid water. The properties, all the properties of liquid water are the same as the solid water. So here there is only a change of state from solid to liquid, whereas the product, it will retain all the properties of the original substance from which it is being formed. So such reactions in which the product retains all the properties of the original substance are known as reversible reactions. Here, the second point is that it only has a change in physical state. That means from solid it turned into a liquid. And generally these reactions are reversible. So even boiling of water, it converts into steam. And when you condense steam, it will again convert into water. So these are known as reversible reactions and they can also be called as physical changes. So this is a new term you are studying today, physical change. Any change in which the product retains the properties of the reactants and the reaction is reversible is known as a physical change. Now what about burning of paper and burning of coal? What kind of reaction do you think that is?
Ma'am, they are irreversible.
They are irreversible reactions. Why?
Ma'am, because the product cannot be converted into original substances.
Very good. So here if you understand, when you burn paper, it converts into ash and smoke. From ash and smoke, you cannot get paper back. So such reactions in which you cannot get the original substance back are known as irreversible reactions. And what are the properties of irreversible reactions? The properties are that the new chemical substance is being formed which will have different properties than the original substance. The second point is these reactions are irreversible generally. And because there is a new chemical substance is being formed, these reactions are also known as chemical change. So here we are understanding a new term, chemical change. Any change in which a new chemical substance is formed which has different properties than the original substance is known as a chemical change. So the examples of chemical changes can be burning of paper, burning of coal, cooking of food. So I hope you have understood what a chemical change is. So we now move on to the next part, which is the characteristics of chemical reactions. Again, let us take some examples from our daily life. Can anyone tell me what happens when a candle burns? What changes do you see when a candle burns?
Its size decreases as wax melt.
Very good. So this is what we have seen every day, that when a candle burns, its wax melts. Also you can see the fumes on top of the flame, which is the vapor of the wax. So this is a chemical change because from the fumes and the melted wax you can't get the original candle back. Here also chemical change is taking place, but here what is showing that the chemical change is taking place or chemical reaction is taking place? It is the change of state. So, the first thing which indicates that a chemical reaction is taking place is the change of state. Let's take another example from our daily life, rusting of iron. When any iron material rusts, we see that it gets coated with an orange colored covering, orange brown colored covering. Now, this is a reaction which takes place with the iron, with the atmospheric oxygen and water vapor which is present in the atmosphere. The iron will react with it to form the orange colored rust. Now, can anybody tell me, is it a chemical reaction or a physical reaction?
It is a chemical reaction.
Very good. It is a chemical reaction because now from the rust we cannot get the original product iron back. So, this is a chemical change. So, this is the other characteristic of a chemical change. The second characteristic of a chemical change is the production of a colored substance like in rusting of iron. Are there any other characteristics of chemical changes? There are, and they are change in temperature. This is a new concept for you. So, please listen carefully. In a chemical reaction, there can be a change in temperature. Either the temperature might go higher or lower depending on if heat is being absorbed or heat is being released. So, depending on this, we categorize chemical reactions into two parts known as exothermic reactions and endothermic reactions. So, let us start with the first reaction, exothermic reaction. Any reaction in which heat is given out during the process of chemical reaction is known as exothermic reaction. Let's take an example of exothermic reaction from our daily life. That is the mixing of quicklime calcium oxide with water to form calcium hydroxide. During this reaction, a large amount of heat is generated. This causes the heating of the container in which the reactants are kept. So, this reaction is known as an exothermic reaction. We notice this reaction in our daily life when you see the whitewashing of buildings. You must have all observed the huge drums which are there, in which the person who is whitewashing the building will be mixing calcium oxide with water, and when they do this, they don't use their hand, they use a long wooden stick to mix the two reactants, because during the reaction a large amount of heat is generated. And this calcium hydroxide, when it is applied to the buildings, it gives that white color after it combines, after it gets dried and it combines with carbon dioxide to form calcium carbonate. That is what gives a white color to the buildings. You must have observed that when the whitewashing of the building is wet, it will not glow white. It becomes white only if it has dried and it combines with your carbon dioxide to form calcium carbonate. So, this reaction of quicklime with water to form calcium hydroxide along with the evolution of heat is an example of exothermic reaction. I hope you have all understood this. Let us move on to the next reaction, which is the endothermic reaction. This is opposite of exothermic reaction. So, in endothermic reaction will be a reaction which is accompanied with the lowering of temperature or the absorption of heat from the surroundings. Since in this reaction heat is absorbed from the surroundings, it causes the lowering of temperature. So, such reactions are known as endothermic reactions. Let us take an example of an endothermic reaction. In a beaker, if we take barium hydroxide and add to it ammonium chloride and then touch the beaker, you will see that the beaker, the temperature has become very cold. This is an example of endothermic reaction. During this reaction, the energy has been absorbed and that causes the cooling of the beaker. So, according to change of temperature, we can have two types of chemical reactions, exothermic chemical reactions and endothermic chemical reactions. Now moving on, the other characteristic, the last characteristic of chemical reactions can be with the evolution of gas. Certain chemical reactions take place with the evolution of gas. For example, in a conical flask, if we take zinc granules and add dilute acid to it, we will observe the evolution of hydrogen gas. So chemical reactions can also be characterized by evolution of gas. I hope you have all understood the various characteristics of a chemical reaction. Let us now move on to another interesting part. When we explain a chemical reaction in a language form, in a written sentence, it becomes very long and confusing. So to shorten that, there is a concept of chemical equation, where the chemical reaction is explained by using the symbols of various elements taking part in a chemical reaction. Such representation is known as a chemical equation. For example, if we take Mg plus O2 gives MgO. In this reaction over here, you can see that magnesium is combining with oxygen to form magnesium oxide. Now, can anyone tell me, recall from the previous year, what is the law of conservation of mass?
Mass can neither be created nor be destroyed in chemical reaction.
That is correct. In a chemical reaction, mass can neither be created nor destroyed. So that means the number of atoms of elements in the reaction have to always remain the same in the beginning of the reaction and towards the end of the reaction. So let me teach you how to write a chemical equation. In a chemical equation, there are two parts, that are the reactants and the products. So the reactants are written on the left hand side and the products on the right hand side. If we take a general equation where the reactants are A and B, so in this chemical reaction you can see A plus B, those are the two reactions which are reacting with each other. There is an arrow which shows the formation of the product, and beyond the arrow we write the product, which is the C. This is a general form of an equation. Let us now take a specific example to show how a chemical equation is written. Now we are taking the example of magnesium reacts with oxygen to form magnesium oxide. Can anyone tell me what is the law of conservation of mass? Do you remember from your previous lesson?
Mass can neither be created nor be destroyed in chemical reaction.
Very good. So mass can neither be created nor destroyed during a chemical reaction. What does that mean? The number of atoms of each element will remain the same from the beginning of the reaction till the end of the reaction. So if we take the law of conservation of mass, do you think that this reaction is correct? Equation is correct? Can anybody tell me?
No, ma'am.
No, it is not correct. Very good. How do we know that it is not correct? We are saying that we have 2 atoms of oxygen in the reactant side and only 1 atom of oxygen on the product side. So we need to multiply the product, that is magnesium oxide MgO, with 2. Now we see that the oxygen number of atoms has become the same, but still magnesium in the reactant has 1 atom, whereas in the product side there are 2 atoms. So we need to put a 2 in front of the magnesium in the reactant side. So this kind of a balancing of equation where we ensure that the number of atoms of each element remain the same is known as the balancing of a chemical reaction. Let us take another equation to see how the balancing of equation is done. This equation is between iron and water. So Fe plus H2O gives Fe3O4 plus H2. Now here we need to balance the equation. So first step in this is that we make square on each of the reactant and the product we enclose inside a square as done in the board. Now please remember, nothing inside these squares can change. We need to balance the equation by multiplying it with simple digits for the reactants and the products. Let us take the element which has the maximum number of atoms in it, either in the reactant or the product side. The number of atoms in Fe3O4 oxygen atoms are 4. So we need to write it like this. You have to put oxygen over here and you write reactant and product on two sides. Here in the product, the number of oxygen atoms are 4. In the reactant side with water, the number of oxygen atom is 1. So to balance this, we need to multiply the reactant water with 4. So in front of that box of water, we need to put the digit 4. Now let us go to the next element which has the maximum number of atoms. If you look carefully into the equation, you will find that it is iron, which is in Fe3O4 in the product side. If you see, then iron has got 3 atoms. So we have to make a similar box for iron, and you will see that Fe3O4 has 4 atoms of oxygen, whereas in the reactant side, iron is only 1 atom of oxygen. So you have to multiply the reactant with the simple digit 3. So in front of iron, you will write number 3. So this balances your iron and oxygen. Now the element left to balance is hydrogen. Again you will form a table for hydrogen. The number of hydrogen atoms in the reactant side now is 8 because it is 4H2O. 4 multiplied by 2 becomes 8 atoms of hydrogen, whereas in the product side it has only 2 atoms of hydrogen. So you have to multiply the product side by 4. So there will be 4 in front of the hydrogen. Now if you see the equation, do you find it completely balanced? All the atoms of the elements on the reactant side are now the same as the number of atoms of the elements in the product side. So this is how we can simply balance a chemical reaction. Balancing of chemical equations by this method is known as the hit and trial method of balancing chemical equations. I hope you have all understood how to balance a chemical reaction and also understood all the concepts that we have dealt today in this module. Thank you so much, students.
Thank you, ma'am.
In this module, you have learned that physical change, process where no new chemical substance is formed. New substance retains the properties of original substance. Change in physical state only, usually reversible. Example, melting of ice, preparing salt solution. Chemical change, process where new chemical substance is formed with properties different than the original substances. Usually irreversible. Example, burning of paper, cooking food. Characteristics of chemical reactions, change in state. Example, burning of petrol or candle. Change in color. Example, rusting of iron. Change in temperature. Example, rise in temperature. Exothermic, quick climb in water. Fall in temperature. Endothermic, barium hydroxide and ammonium chloride. Evolution of gas. Example, zinc plus dilute sulfuric acid.
To watch the next video, please attempt the following questions.
Question number 1. Which is not a chemical change? Option A, digestion of food. Option B, burning of candle wax. Option C, souring of milk. Option D, evaporation of water. Question number 2. In an exothermic reaction, option A, temperature rises. Option B, temperature falls. Option C, temperature remains same. And option D, none of the above. Question number 3. On addition of sulfuric acid to zinc granules, dash gas is released. Option A, oxygen. Option B, hydrogen. Option C, carbon dioxide. And option D, nitrogen.